I left my bag downstairs. I'm just going to grab a pen too. Hold on a minute. Here you go. Okay. Sorry. So I'm just gonna let you know some of the other variables though that I don't really know what to do with either. So with the students on the pre-test, I asked for a bunch of information. So I don't know exactly if I'm gonna end up using it all for this study. It was included in the proposal, so you know there's an expectation obviously that I think I'll do something with it, but I'm just not sure. I have the students' age, gender, ethnicity, whether or not they've taken you know, financial literacy program before, their self-reported GPA, which was, that's the biggest one that my chair really is interested in, the GPA. He would have preferred me to get it directly from the school, but I really couldn't. What they, and then just kind of to ask it again, what grade do they typically earn, and what they typically, what the typical grade is in a math course. And then also with some of the literature, in terms of learning, there's a motivation question. So how motivated are you to learn about this economic literacy? And do they think that their understanding of financial literacy will help with their future success? You know, so they're saying, you know, not motivated, somewhat motivated, motivated, very motivated, or strongly agree, disagree, strongly agree. So, you know, there's all of that. The first thing that I've been asked with this one set of data that I have is to really look at that pre to post change. And like you're saying, with the school and the student and the GPA is kind of the first part that my chair wants me to look at. And then in addition to all of this data that I have on the student, with the pre and post, they also, at the end of the study, filled out a likability questionnaire. And we had worked together on that, you and I, looking at that. It was like a RAINS, REYNES, if I remember, just if they actually liked the person teaching the course. So there was some literature, you know, on that. If they like the instructor, they're more motivated to learn the material, you would think, with better outcomes. So then there are just questions at the post test. Just there were 8 questions. Just, you know, this person is friendly, from very strongly disagree to very strongly agree. This person's likable. This person's warm, approachable. You'd ask this person for advice. So I have all of that too. And then I have a bunch of information on the volunteers themselves, the professionals and the students. So I have from the volunteers who are actually teaching the course, of the college students and the professionals, have their gender, I have their ethnicity.
Oh, there we are.
Sorry. Yeah. I don't know. I don't know if I just lost connection. And then I have, so I can, hopefully we can, continue to work together through.
Yeah. I mean, I think
I can end up sending you these documents, but there's a bunch, just how many times they volunteered, how many hours did they train,
right.
How confident are they teaching the subject matter, and then if they're college students, do they actually work? So there are a bunch of kind of factors that could end up impacting, but I definitely the very first step of just getting some model built is to specifically look at the change in pre to post test, who taught the course, and what the student's GPA. That's kind of the first thing that he wanted me to look at.
Right. Well, I think I think in terms of there are several ways that you can go with this. One way, it sounds like, one approach that you could take on this might be to look at whether the effectiveness of the instruction, what kinds of factors might affect the instructional effectiveness. So in other words, you're really kind of looking at potential moderators of change over time. So, like for instance, there might be student factors. There could be instructor-related factors. There could even be school-related factors that may impact the rate of change or the amount of change that's exhibited from pre to post.
Right.
So, if you're just asking the question of is there change from pre to post, that is, one option, if you were just doing that, would just be to have a control group that doesn't receive the instruction, give the pre-post measure, and then a group that receives the instruction and then give them the pre-post measure, and then just that's just a basic garden variety repeated measures ANOVA. But you probably are, it sounds like you're kind of interested in sort of the conditionality question of what kinds of factors would be associated with the rate of change or the magnitude of change exhibited by individual students, because their rates of change can vary. Some students, maybe they change a little bit, some maybe not at all, some might exhibit substantial changes. So, if you look at the pre to post scores, you might see that some students' post-test scores would be considerably higher than pre, whereas others might be about the same. And so if you're interested in that question, then you can start looking at predictors at the individual level, the instructor level, perhaps the school level, that may have an impact on those differential rates of change.
Right.
So, so in that case, like I could imagine like students' initial motivation level might be one factor. Like if they come in there and they don't really care about learning anything, then you can pretty much imagine that the instructor teaches and it doesn't have any impact on their pre to post, so there's no change.
Right.
Whereas other students who are more motivated, maybe they exhibit a more substantial rate of change. So if you are, or another possibility is, let's say that you have a student who is low, go back to GPA. Low GPA could reflect a number of different things. It could reflect low general academic motivation, or it could reflect low levels of prior knowledge, which could also then have an impact on how people process the information when they're in the literacy program. So in that case, it could be that low GPA could if certain variables that correlate with that, it could be that maybe low GPA translates into low rate of change. On the other hand, it could be that in certain circumstances, maybe the converse could be true. I don't know what that would be, but so you can look at the individual factors related to the student that impacts the I guess you could say the slopes or the rate of change. Then you have the interesting question about the instructor. is the instructor a professional who's been in the business for a long time and understands this stuff off, just right, very easily? It's, has sort of a natural language for talking about this, or is the instructor a novice? So then you get into this question of novice versus professional, or novice versus expert, and whether or not that has an impact. So it could be that between novices and experts, that you see that the classes that are taught might exhibit differential rates of growth on average. You could also then have, that, if you wanted to look at, how do they feel about the instructor? Were they a likable person or warm or whatever? Then you could have those kinds of characteristics also as possible moderators. And then even further than that might be just the issue of school-related moderators, like in schools that have low rates of, low resources. Maybe that has an impact on where students are at and when they come in, and so then that might have some kind of effect. So you can, as you're talking about from that, if those are the kinds of questions you're interested in, you can look at it from a multi-level perspective. So in hierarchical linear modeling kind of approach, where you would have essentially the repeated measurements, the pre-post measurements being nested within students. So the pre-post measures are at level 1, student level is level 2, and then you could have the classroom level at, say, level 3, which so you would have variation within students, variation between students at level 2, and then variation between classes at level 3, and that's where you could model those instructor characteristics.
Within the level 3, and then level 2 would be the student level characteristics.
Yeah, so you'd have variation in performance on the so you'd have the same measure given at pre and post for all the students, and but so you would have that at the student within students, you would expect the difference. You would expect there to potentially be change from pre to post. So you'd have variation there. Then you would have between student variation in both their sort of average performance as well as perhaps the rate of change that's taking place. So that would be looking at differences between students in the slope coefficients, and then also then you could model predictors of that, and then you could then have between class variation.
Right.
So what I'm basically saying is that, yeah, I mean, if these are the kind of questions you're asking, if you're asking really about the question of what kinds of student and instructor level characteristics predict variation in students' financial literacy, and also basically the rate of change that's exhibited, then then basically you're really looking at a multi-level type of design.
Yeah, I think what you said is exactly what I can picture now with these levels, and where they fit in. Because I think each point, I mean, there's literature that touches upon almost all of the variables that I've kind of included. That it's not just kind of completely out of the air thinking. It's just I couldn't picture how they would all fit in. So with the very start of it, when you build these models like in SPSS, if I have the data to show the change between the pre and post, so that would be just this, you're saying this level 1 kind of repeated measure level variable, right? And then level 2 for the student level, I think to start, just to put in even just their GPA as just kind of a first piece. And then I guess just for right now, for the level 3 of the classroom, to know, is it a professional or a college student who's actually taught the class, and then also which school it actually is, right? That could be in this classroom variable.
Yeah, I mean, let me see if I can. I'm going to call up because I was teaching HLM in the spring, and so let me just kind of show you what a data set might look like. Let me see here, data. Okay, so HLMs. Okay.
Because when I did this for that preliminary data, all I had for information was the pre and post test. And I mean, I knew the students individually, but I didn't have any anything that I was looking at student specific. So then it was just, we created dummy variables. We did it through a regression analysis because it was a regression class that I was taking. But I think we could, at first I was looking at it just through t-tests, and that would have been fine to analyze. But from the regression standpoint, we created the dummy variables. There were 3 different schools and just coded them like 0, 0, 0, 1, 1, 0. And then that was how I was able to run it. So that's all I know how to do.
Well, how many schools do you think you would have?
I'll end up having 6 schools.
6 schools. But how many, all right, so how many classes do you think you would have?
Ideally, there would be probably maybe close to 40 classes.
Okay, so yeah, this would be ideal at a minimum, you know, with HLM. Yeah, 40 classes.
Pretty nice. Okay, so let me show you. I'm gonna screen share here. Okay, so can you see my screen? Yes. Okay, so this is a data set in SPSS that that I was using in the springtime to demonstrate some basic multi-level modeling. So this right here, now there's no repeated measurements in here, but the same general principle applies, which is that when you're talking about multi-level modeling, you're talking about data that are nested within different levels. So you have level 1, like is sort of the if you're dealing with cross-sectional data, that would be the you would have the outcome variable as well as any predictors at level 1. So this data set right here, this is a set of student data. So you have, the ID variable represents each individual student ID. Okay. You also see that each student, these are all the students, these are nested within schools. So you can see that these are the first 12 students in school 1. These are the next set of students, and they're in school 2. Right. And so the basic idea, and then, then when we have school 3, all of these students, they're nested within that school. And the basic idea is that when I'm trying to predict variation in an outcome, like let's say the outcome variable is maths achievement score. The deal is that that because of the nesting structure, because the students are nested within schools, what can happen is that that we have essentially a violation of independence when it comes to the observations. And what that translates into, if I was to run a standard regression analysis with, like, let's say gender and socioeconomic status as predictors of math score, the standard errors will oftentimes be deflated because of the violation. All right. And what that translates into is an increased likelihood of a type 1 error when it comes to predicting variation in math scores. So when you have nested data, what happens is that because you have correlated observations, it generally, the effect is to shrink the prediction errors within those contexts, and it increases, it essentially deflates the standard errors and increases the likelihood of type 1 error. So that's one of the reasons why you might adopt, say, a multi-level approach as opposed to a standard least squares regression that does not make that assumption, makes that assumption. Essentially, the multi-level approach helps to correct biases and standard errors due to the nesting of the data. The second benefit, though, is that you can also model variation across those higher level units in terms of the predictive relationships. So to give you an example, like let's say I want to look at the relationship between socioeconomic status and math scores. If I was to look at this relationship just with the, we'll put SES in here and we'll put math score here. If I just look at this information in the aggregate, it looks, this is kind of the general way it appears, right? And actually, I'm going to use a smaller subset. What cases? I'm just going to use the first school code will do equals.
So I'm just wondering, I don't know why I'm asking, but I set this up. If you go back to that Excel screen that you had, or not the Excel, the SPSS input. Okay.
So what you'll see is we have a student identifier, and then each student is nested within a given school. So all of these students right here are nested within school 1. All of these students right here are nested within school 2, and so forth. So there's like, in this particular data set, I think there's like, well, in total, there's like, almost 7,000 students nested within 419 schools. So the deal is that each student will have a score on the outcome variable. So these are the scores on the outcome variable at level 1. And female, gender and SES are examples of level 1 predictors. So these are basically variables at level 1 that would be used to predict math score. But then there are also school level characteristics, like say the average socioeconomic status associated with school 1. So the average socioeconomic status for school 1, average for school 2, and so forth. Whether or not it's a public school or a private school, those are also characteristics at the school level. So it may be that, say, the relationship between SES and math that we observe at level 1 may vary between schools. Like in some schools, this relationship may be stronger than in other schools.
Right. So if I try to set this up and I have, like, if right now I just want to look at GPA, instructor, school, and the change in the pre and post, and I have the schools. So I only have one school right now anyway. So, but I have the school for student identifier. I don't know what I'd use. I have their first 3 letters of the last name and their date of birth. I could use something like that to identify them. And then the GPA, instructor, so professional or college student. And then I think just to look at the change in the pre and post test, because the higher change will obviously be the better result. So if I have that change in the pre and post, that is the level 1 measurement, right?
Yeah, so let me show you. Here's probably more analogous to what you're talking about. So this right here is an example where we have a set of students. This is the student ID, and they're nested within schools. So this is school 1 for these first 12 individuals, school 2 for the next set of individuals. We have test 1 and test 2, and this has actually got a test 3 right here. And then we also have some other variables like the student socioeconomic status. And I can't remember what this variable was. This might be a school level variable, but or not. I can't remember what that was actually. But anyway, what you would do is essentially, you know, create.
Are you able to, Mike? Are you able to make your screen just bigger? When you go into the files, I can't see exactly what you're clicking on.
Oh, well, I'm just opening up a new data set because the data actually has to be structured more along. Let me find it here. There it is. This way. And I'll kind of give you an idea about what it's going to look like. So, for instance, you know, let's say these are. Let me find my time variable here. There it is, and there's test. Okay. So to give you an idea, let's just say that I'm going to just select. I'm trying to remember the example that I was using. ID, student ID. So we'll do that.
This is what I don't. Are you able to make it any bigger? I just can't see what you're clicking on. Because what I think I'm following you. If I have this data set and I actually input it in to create these different levels, how do you do that in SPS? So if SPS,
well, this is gonna take. Right now, I'm mainly just showing you, kind of giving you an idea about what to. Don't worry about so much the following. I have videos on this anyway, so and I'll send those to you. But what I was trying to show you is like this data set right here. Can you see it? I mean the output.
Kind of.
I wonder if I can. I wonder if I can. Style. I guess it's about as much as I can do. Well, I'm recording this, so you can look at it too. I mean, can you see the plot that I'm showing you?
I see it's a graph. I just can't see what it says.
Okay, so these are test scores, and these are the measurement occasions. So this is time 1, time 2, time 3. This would be like a pre-test, post-test, and a post-post. Okay.
Okay.
All right. Now, what I've done is I've structured the data so that if we were just looking at this in terms of like repeated measures ANOVA, then essentially what we're doing is we're testing variation in the in the means. So there's like the time 1 mean, time 2 mean, time 3 mean. Now, but it's possible that the growth rates for the individual students vary. So for instance, I'll show you, like if I go to, oh, dang it, I guess I can't do that. Oh yeah, now I remember. So to show you what that might look like, I'm going to add ID to this button right here. And so now you can see everything's kind of in color. And these are the individual growth trajectories. So you'll notice, darn it, I don't know if I can get rid of that. You'll notice that with some of the students, let me rerun this and get the equations off of there. All right, so that'll come up. Let me get that off. So you'll notice, kind of looking at this, that some students, like this is one student's growth trajectory right here. These are pre, post, and post, post. And so there's a fit line that's fitted to that data. Then you've got another student with a little bit more flat profile. You could even theoretically have some students that that theoretically could actually exhibit a negative profile. Yeah. Okay, and so what I'm basically driving at is that with the multi-level approach, you can look at individual predictors of the rates of change. Like each of these would be a slope. That would be the slope for one student. This would be the slope for another student. This would be the slope for yet another student. So all of these slopes right here are reflecting growth trajectories. for each of the individual students. And this is just the first 20 students in the data set. And so what we could do, or what you can do, is essentially model, student characteristics. Like, for instance, maybe GPA might account for why some students exhibit a more pronounced growth profile than others, or it might be their level of motivation. Another possibility is the school that they're in. Like, it could be that in some schools the rates of change might be more flat, whereas in other schools maybe there's more pronounced change. So the point I'm trying to make is that what we're essentially looking at is the possibility that there are, there could be student level factors that impact the growth trajectory, and there could be even higher level factors like school related factors that might impact those trajectories as well. So if you're looking at your particular data set and the way that you're setting up your problem, theoretically, you could have measurements at, say, time 1 and time 2. And maybe, you have sort of, if you just look at it from time 1 and time 2, if you just run like a paired samples t-test or something like that, you'd just be comparing the means between the two groups and looking to see if there's a general tendency for perhaps an increase in financial literacy. But the thing is that this ignores the possible differences among your students in terms of their growth trajectories. It could be, for instance, that maybe this person exhibits a flat profile. This person has a little bit of a change right here. You could have a person down here where they're exhibiting even a more pronounced change. And and let's say this person actually decreases. So you could actually model individual level characteristics that are affecting or maybe predicts the slopes. And you could also model higher level factors like the instructor characteristics, because so essentially what you have is, you have the repeated measurements on the dependent variable falling at level 1. The repeated measurements are nested within students. This is at level 2, the student level. And then potentially you could look at, classroom level, where the students are nested within those classrooms. And then you can model, instructor characteristics that may predict variation across classes, with that variation across classes being part of the, explaining part of the variation between students. And so then you can break it down into components that may help to explain why some students exhibit greater rates of change than others. And you might be then able to kind of attribute those differences to student level characteristics and class level characteristics.
Okay.
Does that make sense?
Yep.
So, I mean, it really is just it's essentially, when we talk about this type of design, essentially this is a growth curve model, where essentially what we're doing is we're looking at the rates of change that are occurring at, within students. So essentially we're looking at variation in scores at level 1, reflecting sort of differences in the rates of change. And then we can look at student level moderators. So, the type of student, maybe maybe this trajectory right here, this one right here, might be reflecting a low motivation student who starts off low in financial literacy and doesn't really change. We could have, in this particular case right here, we could have a student who starts off high in financial literacy and is not really motivated either, or maybe they're already at the top anyway, so there's no effect. But the point is that you can look, the differences in the growth profiles can be reflecting differences between students, and you can identify student level characteristics like motivation or GPA or interest in the subject matter. And then also part of that, those differences might be attributable to school or excuse me, classroom level differences with their respective instructors.
Right.
So you can get down into some really nitty gritty hypotheses about, higher level factors that may be impacting the growth trajectories.
So all of those factors that have that impact, they would all be considered moderating variables?
If you're talking about the rates of change, then essentially you're looking at moderators of those rates of change. There's
Right.
more nuance than just that, but that's, a lot of times people are mainly interested in that kind of question, whether, higher level factors are impacting the growth that you're seeing in the students.
Right. Okay.
So that's just basically like I said, that's just basically a growth curve model.
Right. Okay.
But to do that, you'll have to learn a little bit about HLM.
Yeah. And that's, what is it?
Hierarchical linear modeling.
Yeah.
But I have a number of videos. I think I've got them in playlists, so I'll send you some. And but the nice thing about this approach too is it really gets you thinking more about the way that data really often appear to us. Really, a lot of times, the variables that we're working with are nested within higher level units. So we don't really think about it, but like, for instance, if I'm surveying a group of, if let's say I'm going to send out a survey on work motivation to workers at 15 organizations, those workers are nested within the organizations. And so what happens is that the workers, work motivation, by virtue of falling within those organizations, there are organizational factors that are more likely to create a similarity in their responses. So it's not like a random sample where you just sort of where you have sort of a greater independence with respect to observations, but like in cross-sectional data, a lot of times when you are sampling from individual organizations, that's your initial sampling unit, and then you sample individuals within. What will happen is that you'll have sort of a clustering of observations where responses are more similar within organizations, and there'll be differences between organizations. And so then when you start modeling predictors, like individual predictors of variation in, say, work motivation, what can happen is that can bias the standard errors in your regression analysis. And so one reason why you might use multi-level modeling is that it does help to kind of yield unbiased standard errors. But the other payoff is that you can really get into modeling both individual level and organizational factors that may be impacting the outcome variable. And then we can take it even further then, and as you can see, we can even talk about nesting a little bit further by looking at nesting of responses on a measure. If you're measuring repeatedly, then you essentially can look at those repeated measurements as being nested within individual, and those individuals in turn are nested within different classes.
All right, that makes sense with all these variables and kind of what I want how I want to use them. So then the process, though, to put it into SPSS is more difficult, or it's something. It's not an. Not an easy.
Well, I mean, what you can do is you can start off by setting it up in this kind of way right here, where we've got you would have the individual student. Like for your particular example, you'd have, let's say, pre-test and post-test.
Right.
And then you would have, the instead of school code. Well, I would collect data on the school itself, but I would give each classroom a code. So you could have class 1. So you'd have the students in class 1 right here, students in class 2, and so forth. They receive a pre-test and their post-test. You might have individual student level characteristics like this variable and this variable, or you could have like this variable could be gender. This variable could be SES. You could have GPA or whatever, motivation or whatever at the student level, and then you would also want to have I would also then maybe I can help you organize it and set it up where you could put in the instructor level variables as well. But you would need the class. Also, my suggestion would be that for each class, you would also have just an instructor code.
Right. Yeah.
I mean, basically the class code should be associated with a given instructor. So you could just say, call this instructor 1 or something like that, and or whatever. But just make sure that you can identify which class has which instructor. Actually, to tell you the truth, if the same instructor is going to instruct in 2 classes, like let's say for instance we have, so let's say we have class 1, and let's say class 2 is also taught by instructor 1, then you would you would want to have the same code for those, because then you've got essentially the same instructor teaching. Do you have it set up that way, or do you actually have a situation where
it's possible, but probably not likely. I'm thinking it would be a different for each class.
Well, just on the off chance, go ahead and I would also create an instructor code. And even if that doesn't happen and it turns out that the instructor code mirrors the class exactly, at least you could, if there is a circumstance where you have an instructor who happens to teach 2 or more classes, you'll want to be able to identify which classes are associated with that same instructor.
Right. Okay.
So,
once I set this all up, and then it's all, because I can envision my Excel sheet of just for the import. When the information comes out, I mean, showed me the graphs, but it will show me. So it doesn't show like these. Does it show as like, will it show which seems to have the most power as an influence on the change, or
so
ranks it or whatever?
Let me show you what it'll look like. So let's say I'm going to run a basic model where I've got so everything's nested. We're just going to say nested within student, and we'll use repeated. We'll just use time right here. So let's say we've got essentially tests as our dependent variable, and let's just say I want to model whether there's variation between students in terms of their growth trajectory. So in that particular case, I mean, basically, it's really hard to explain in just a very short amount of time. But
that's okay. Yeah, this has already given me enough, I think, to get the ball rolling. Because again, I didn't know what to do with all of these variables. I just couldn't envision what it would look like. But this is giving me now buckets to think about them in these levels.
Yeah, I mean, basically, the idea, like for instance. Right here, I'm just looking at is there variation in the slope over time. So, and this is assuming a linear rate of change. So essentially,
Yep.
we've got, this is the effect of, this is the effect of a time variable, and it's significant. So across all of the students, the effective time would be considered significant, meaning that essentially, and it's positive, meaning that there's a significant positive slope, meaning that students, on average, their test scores are increasing. Now you can get more.
That's my first hope, is that there's some significance.
Right.
Just in time pre to post. I mean, because
and
actually,
so this,
go ahead.
Yeah, and in many ways, this is just kind of capturing what the, I mean, it's just basically modeling that overall effect. Then down here, you can see that we've got, the intercept is really reflecting the way this is coded in the data set. I believe time 1 was coded 0. This would be variation between students in their initial levels on the outcome variable. And then this right here is modeling, determining whether there's significant variation between students in those slopes.
Right.
So, and so this is significant. So it actually suggests that there might be some other factors that may account for why there's, these slopes are varying.
Right.
So then you can just basically start modeling predictors of that variation. So,
okay.
For example, let me see here. What we got? Let's say SES. So I'm going to add SES and then basically we start to model
building.
Building an interaction effect. So for instance, it may be that SES moderates the slope. So I can look at that as well to see. And so in this particular case, you can see time by SES. That's an interaction effect. So it looks like, and it's statistically significant. So it looks like that the variation that we were observing down here in terms of the slope, part of that variation between students is maybe attributable to their different levels of SES.
Yeah, this is exactly what I'm hoping to be able to do. Okay, so, I get it.
Yeah, I mean, so that's the basic idea. So you're really, so this is, like I said, this is called growth curve modeling, and the basic idea is that you can use multi-level modeling in order to look at student level and kind of class level characteristics. Which one of the class level characteristics would be the instructor, expertise or whatever. And then so you could look at variation in growth trajectories as a function of, whether the instructor is expert or novice, and then you could look at the individual characteristics, and that would make be potentially a really valuable addition to your literature, because a lot of times what happens is that we tend to if you just ask the question, are there gains in financial literacy, all you're doing is you're looking to see are there gains on average, but you want to be able to reach out to those students who might not be able to gain under a traditional curriculum. It may be that you have to, with certain students, you have to focus your attention in other areas to either increase motivation or to increase their engagement, those sorts of things. And so you're really kind of addressing a question of not just does financial literacy have an effect, but really what kinds of factors condition the effectiveness of the intervention.
Right. So, like, let's say for gender, I could say 0, 1, and I know what 0 and 1, and then say ethnicity, I have, say, Hispanic, white, Black. I could just code each of those like a 1, 2, 3, 4,
well,
whatever. Is that?
Well, yeah, you could. You probably want it dummy coded. I mean, you can use technically. You can.
what will happen is you can either have the program do it for you and by treating it as a factor, or you can do the dummy coding yourself. I generally prefer to do it myself, because essentially what you'll have to do in that case is kind of establish dummy variables with a reference group, and then if you kind of go back to your regression class, that's what that's all about. But yeah, I mean, you can model all these different things in there, and but like I said, probably the bigger ones might be, well, I would include gender and check out also ethnicity, potentially at least as sort of as just general predictors, and then you could incorporate like motivation or GPA or things like that, and then and then those teacher level characteristics,
right?
And then when you ask the students, like, how'd you feel about the teacher, like, did you like them or whatever, then you could take an average for the class of their perceptions of the teacher, kind of aggregate and just create a class mean, which would be a characteristic of the class itself. And then you could include that along with, the instructor expertise as a predictor of variation between classes.
Yeah. Yeah, that's a really good idea. Would it, so with, because there is maybe a student level with the motivation, I would just wonder if that particular student is more motivated or not, affects their particular change.
Yeah. I mean, that's just another predictor at the student level that might predict the rates of change observed at level 1. So essentially, what you'd have is just a student level predictor predicting variation in the slopes, reflecting those growth trajectories. And then, like I said, then you can add in the class characteristics that may affect kind of between class variation and the average rate of change. And so, yeah.
Okay. And then just because my chair, I have a feeling that he's going to think more about like a least squares type regression. So could you still do all of, I mean, what you're saying makes the most sense to me. Like I get it. I can see how I can say what I want to say once I understand more of this model, but just from the high level, like it makes sense to me. But using a regression model, could this still all be done that way? I'm just thinking
well, it's not as flexible, and then on top of that, you're back to the problem of violating the independence assumption. So you're going to end up, and then essentially, you're not going to be controlling for. It's just not nearly as clean, and you're probably going to have the problem of correlated observations, correlated residuals. Which is going to violate that assumption. So, and this is nothing more than an extension of regression anyway. It's not.
Yeah, no, it's still looking at the slope, and I mean, it's all, yeah. Because with that correlation, that's when, what is it, when the variables overlap each other? Or I remember looking at the correlation matrix. I just don't remember.
Well, I mean, what happens is that, the idea of independence is that, if I have a set of observations and I select them in my sample, that those observations, that the likelihood of, selecting one observation is unrelated to the likelihood of selecting another. So each observation is independently, it's like if you roll a die that's completely unbiased, it does,
the fact that a 6 comes up on one roll has no effect on the likelihood of a 3 on the next roll. They're all equal probability. But what happens is that when it comes to like repeated observations, you have dependence there. But the procedure accounts for that. But what happens is that when you have a nesting structure, then the observations are not fully independent. They're basically I don't know how else to put it, but
I know they're within something already versus independently or what.
Yeah, you're not randomly selecting observation. So what happens is that it's easiest to think about it in terms of kind of going back to the organizational approach where you say I give a measure of work satisfaction to individuals. So let's say I find 15 organizations and use those as the basis for getting my sample. So I select 15 organizations, and then from those I select individuals from those organizations and measure them on their work satisfaction and maybe other variables. So what happens is that the people within those organizations are more likely to be similar than different. As a result of sort of interaction, how people talk around the water cooler about the organization, those types of things. Whereas if I wanted to study, organizational work satisfaction more generally and have more of an independent sampling, then theoretically the universe of organizations would be, I could select, I'd be drawing random samples out of any person within any organization. And I'm not selecting an organization and then sub-selecting a sample from that. Instead, I would just be randomly selecting out of, any number of organizations. And so there would not be those dependent observations kind of cropping up in the same way.
Right. All right. Well, you've motivated me to start working on this stuff. A little kick to get going, but okay, I know what I need to start doing. So I'm going to get my Excel file organized with the data that I have. I'm gonna try, to code, I think, like how I'm thinking, but I don't know if
well, here's what I'm going to do. I'll send you my web link. There's also a really good book that I use in my HLM, because part of this is you're going to have to learn how to think multi-level.
Let's see if I had a book like that. Okay.
Let's see if I can find where to put it. I gotta clean my office. Maybe it won't. So anyway, there's a more recent version, but when I send you the website, I reference this book all the time, and but I would get a copy of it, and you can follow along.
What is it?
It's actually it's by Ronald Heck and Scott Thomas. It's called Multi-Level and Longitudinal Modeling with IBM SPSS, and it's a really good book. And really what you're going to have to do is be thinking, like I said, in terms of multi-level. It starts off with showing you how to do multi-level modeling with cross-sectional data, and then it moves into essentially there's a chapter in here on examining individual change with repeated measures data. That is essentially the growth curve modeling stuff. That's actually in chapter 5. But you'll need to read through and think about, because they also talk about data management and stuff like that, and how to set up
you know, they talk about setting up databases and so forth. You can also
Okay.
download data from their website and actually follow along with the examples. But in the videos that I have, I walk you through a lot of that. So,
Okay.
but I would really start there. If these are the types of questions that you're really trying to address,
I
then
think this is really what I'm trying to address. I mean, to be able to then pinpoint why these changes are happening at these different levels, or, you know, I mean, specific reasons. I mean, that's exactly what I want to be able to point to and say, or to, I mean, I don't know if it will end up being able to tell me that, and one big question that I have is regarding gender, and, you know, do the female students come in with lower pre-test scores, but ultimately come away with higher post-test scores, or show a higher degree of change from pre to post? Because there's a lot of literature that suggests that. Or, you know, I mean, GPA seems to be kind of a given, but then it gets confusing, because would their pre-test already be higher because they're better students and taking the pre-test more seriously? So maybe their growth won't be as high, but I don't know. So, I mean, there's a lot of questions that I have, that I just want to be able to say, okay, the change did occur. You know, that the programs are effective in the sense that they take this program and they've learned something. We think, you know, the test is higher, but then because of all the different degrees of how the individual students will change, positive, STEAM, or even negative, why is that happening?
right. And that's, yeah, I mean, you're basically talking about the question of conditionality, where, you know, that not everybody responds to the same stimulus in the same way. And,
right.
You know, and not all students, just because you provide an instruction, not all students are going to respond the same way. And, you know, if there are, you know, groups that are less likely to be served by a particular instructional intervention, or you would want to be able to identify that, you know. And so,
right.
So that to me would be kind of where your payoff is.
Yeah, I think so. And then, I mean, Junior Achievements is a huge worldwide, really, organization. And, you know, on my committee, there's Junior Achievements on my committee who is in charge of their research and data. You know, so they're interested in this. You know, they want to see what are these factors that could make the program better from an instructional standpoint too. You know, the students are kind of almost, we get what we get in terms of the students, but then with the instructors, like, you know, that original data that I had seemed like the college students should not be teaching these courses, that, you know, and I want to be able to say that more strongly, or to be able to say, here's the issue. How do we help these college students go in and have better success when they are volunteering, like the professionals? Not to say they can't teach, because they really need any volunteers they get, but, you know, just to be able to have some solid data to have these good conversations to ultimately help these programs be stronger and more successful.
Right.
So cool. All right. So I guess right now in my head, though, like the way you've described it, and I know, you know, I'm sure once I start digging in, nothing's as easy as it seems. It seems easy to me. Like, I don't know. I'm just wondering the big difficulty in setting up these models, because I just feel like if I have all these variables and I'm kind of just, I don't know, putting them in my Excel sheet of what I've been, you know, I know what they are. I know that will come with the reading, maybe understanding more, but I don't know. It doesn't seem like, but you're saying the models are difficult to build.
Well, you just have to, I mean, there's the how-to part, and then there's just thinking in terms of kind of the multi-level framework. So I think what you're going to need, because you're also going to have to be able to explain this to your committee, and how, you know, how this, and what you're doing, and why. And so
my suggestion is I would get a copy of the book and start there. I'll send you some articles that that are good reading material as well for thinking about, because it really is kind of explaining why you're using a multi-level approach. You know, I mean, there are good reasons to do it. There are good theoretical reasons as well as statistical reasons to do it. And and I'll send you those videos or links to the I put them in playlists now, so you can start to kind of go through and learn. So when you get the book too, you can kind of follow along with the video presentation in relation to the book, because I kind of did it that way. And then, but start off with the cross-sectional stuff first, because that'll give you a chance to kind of be thinking about in that context, and then that's a good precursor then to moving into talking about growth curve modeling. So don't skip over to the growth curve stuff. You'll have to you'll want to go through the cross-sectional stuff before you get to the growth curve stuff. Okay.
Okay. So you'll send me that book. You'll send me the information on that book.
Yeah, and you can just order it from Amazon or whatever, and then like I said, I'll send you the video links, and then we can just kind of go from there.
Okay. And just my last question is, I'm assuming that this is a model that like most people, like my chair, would know about. You know, like is it kind of a common statistical model that you see? I don't remember reading about like this type of modeling in papers that I've read, but I think, you know, so many of my articles that I was reading were finance, you know, and it was more, I don't know if it was really this. I'm just kind of anticipating the conversation with my chair before I get too deep in it.
Yeah, I mean, it's you know, if it's not, I mean, it's a fairly widely used. It's not, you know, a lot of people don't use it because they don't think at that, you know, in terms of these multiple levels. And also, you know, they can be a little tricky running statistically, but once you kind of get it down, you know, it's pretty straightforward. But it does take a, you know, we oftentimes think about everything in a single level, and so we end up measuring things at a single level, and we're not really thinking in terms of that nested kind of those nested concepts. So, but yeah, you should be able to explain this. You know, it's just a matter of, it's just a to me it makes sense, you know, to approach it your problem from that perspective.
Okay. All right. Yes, you the kids. My husband just left for work, so this is a good stopping point. But all right, Mary Kate, hold on a minute. All right, let me get my head around it and start thinking about how I'll put this together. And yeah, I'll end up probably, once I have my head around it better, reaching out to my chair just to kind of put it out there to him, because he can be a little different. So okay.
But just keep in mind, I mean, the whole point is that you have to pick the tool to the correct tool to address your research question. So, you know, you shouldn't be kind of thinking, well, I need to do a regression dissertation or an SEM dissertation. You should be thinking, these are my questions. These are the hypotheses that I'm forming.
Yeah.
And then you pick the procedure, and these are the measures I'm using. So you have to pick the procedure to match those things.
Right. Okay.
Okay.
Well, thank you. This was awesome. I will definitely be in touch again soon if that's okay. And,
sounds great.
Okay. Sounds good. Thank you so much. Nice to see you too.
Good to see you too. Have a good one.
Thank you.
Bye.
Bye.